So when we are solving each equation on the interval from 0 to 2 pi, we are essentially, we're dividing. We have to start by getting this sine x by itself, here for number 16. So we're going to first divide by 2. So we have sine x equals 1 half, sorry, negative 1 half. And now we use our unit circle to figure out sine of which angles between 0 and 2 pi give you a y value, since it's sine, of negative 1 half. So we're just looking at where does sine of an angle equal negative 1 half. So we go to our unit circle, and we see where does sine equal 1 half, negative 1 half. Remember, sine is the y value, so we know it's at negative 1 half here, and negative 1 half here. So between 0 and 2 pi, just the angles that are on the unit circle, you get 11 pi over 6 and 7 pi over 6. So we're at 11 pi over 6, so x equals either 7 pi over 6 or 11 pi over 6, or and 11 pi over 6. Two different answers. All right, this one's similar. Again, it's just a cosine, so we want to start by getting cosine x by itself. So we're trying to solve for that. So first thing we want to do is subtract root 3 from each side. 2 cosine x equals negative root 3 divided by 2. I get cosine x equals negative root 3 over 2. So we're trying to figure out cosine of which angles on the unit circle between 0 and 2 pi give us an angle, a x value of negative root 3 over 2, since it's cosine. Cosines of which ones equals negative root 3 over 2. So we looked at our unit circle. Cosine is negative root 3 over 2. Cosine's x, so we got one right there and one right here. So our two answers are 5 pi over 6 and 7 pi over 6. So 5 pi over 6 and 7 pi over 6. So we go back to our answers. We get x equals 5 pi over 6 and 7 pi over 6. So those are our two solutions to that problem right there. All right, on to this next one. So what we notice is different. This one has a 2x in it. This means we're going to have to use the general form of the equation to find all the solutions in the unit circle. So we want to start by getting sine 2x by itself. So we're going to subtract root 2 from each side. Get 2 sine 2x equals negative root 2. Divide by 2. I have sine 2x equals negative root 2 over 2. So we're looking for where the sine of the angle, where the angle is represented by 2x now, equals negative root 2 over 2. So it's unit circle time. Let's go back to our unit circle. Figure out where sine is negative root 2 over 2. That would be right here and right here. Those two angles, 7 pi over 4 and 5 pi over 4. So those two. But this time, because there's a 2x, we have to use the general form. So we say 2x equals 5 pi over 4 plus 2 pi n, and 2x equals 7 pi over 4 plus 2 pi n. So those are our two, that's the general form of each equation. And we're doing this because it's 2x rather than just x. We know there's going to be two answers from each one of these. And it's two for a number of reasons, but it's a shortcut. Whatever this number is, that's how many solutions we'll get between 0 and 2 pi from each one of these general equations. So we divide by 2, solve for x. Get x equals 5 pi over 8 plus 2 over 2 is pi n. And remember, we got 5 pi over 8 because 5 pi over 4 divided by 2 is the same thing as multiplying by 1 half. So really we did 5 pi over 4 times 1 half rather than dividing by 2. So that's where we get this. So here's our first equation. Second equation we divide all these by 2. We get 7 pi over 8 plus pi n. All right, so now you use these two equations and we solve. Well, so essentially, the first two answers are 5 pi over 8 and 7 pi over 8. So x equals 5 pi over 8 and 7 pi over 8. Then what we have to do is add pi to each one of those. So if we add 1 pi to this, really we're adding 8 pi over 8 since we want a common denominator. So 5 pi over 8 plus 8 pi over 8 would be 13 pi over 8. I do the same thing here. 7 pi over 8 plus 8 pi over 8 gives me 15 pi over 8. And those are all the individual answers between 0 and 2 pi. And we know to stop there and not continue adding pi's, because if I added pi again, I'd be at 21 pi over 8, which is more than 2 pi. 2 pi is 16 pi over 8, and we only want the answers between 0 and 2 pi. Okay, so moving right along, we've got 4 sine squared x minus 3. So got to get sine squared x by itself, so add 3. 4 sine squared x equals 3. Divide by 4. That's sine squared x equals 3/4. Remember when we squared, we have to square root it. So sine squared x equals, sine x equals plus or minus the square root of 3 over the square root of 4. Remember, we can write that as plus or minus. And it's always plus or minus when you take a square root. But the key here is rewriting this as plus or minus the square root of 3 over 2. Because the square root of 4 is 2. And one of the properties of radicals is fractions inside of a radical can be split up. So we're looking for where sine of some angle is positive or negative root 3 over 2. So we want the y value, since it's sine, to be positive or negative root 3 over 2. So we've got this one, this one, this one, and this one. So all the pi over 3s. All the pi over 3 angles. So x equals 4 different places, 2 from positive, 2 from negative. So pi over 3 and 2 pi over 3, those are the two where it's positive root 3 over 2. Then 4 pi over 3 and 5 pi over 3. That's where it's negative root 3 over 2. And those are our answers. All right, moving right along. It's a little larger. There we go. Okay, so when we're in this factored form, what we want to do is we want to set each one of these separately equal to 0. So it's kind of 2 equations in one. So we start by solving this one. 2 cosine x minus 1 equals 0. Solve that equation. We'll get x equals something. And also solve this one. Tan x tan x plus 1 equals 0. Solve that, get x equals something. And then all these together will be our solutions. So it's kind of 2 problems in one where all the answers are put together. So we solve for cosine x, add 1, 2 cosine x equals 1, divide by 2. Looking for where cosine x equals 1/2. So we go to our unit circle, see where that is, where cosine x equals 1/2. And that happens to be, where cosine's 1/2, we want the x values to be 1/2. So pi over 3 and 5 pi over 3. So those two. So for this branch of the equation, it's pi over 3 and 5 pi over 3 is our 2 answers. And then for this branch, we solve this, subtract 1 from each side, get tan x equals -1. I'm looking for where tangent is -1. Remember, tangent is y over x. So I want y over x to be -1. And you might remember that tan x is 1 at either the pi over 4s or negative pi over 4s, or all the pi over 4 angles. And we know it's negative whenever the signs are opposite for the y and x. So at 3 pi over 4 they're opposite, and at 7 pi over 4 they're opposite. So those are the 2 locations where tangent equals -1. So we've got 3 pi over 4 and 7 pi over 4. And those are all our answers for this equation. And that'll be similar to this problem when we do that. Okay, so we got another squared one. So we know we're going to use square root method for this. So get the cosine squared by itself, add 1 to each side. Cosine squared theta equals 1. Square root, we're doing plus or minus. So plus or minus the square root of 1 is just plus or minus 1. So we're looking for where cosine theta equals positive or -1. Well, cosine theta is x, so we're looking for where x is positive or -1. That would be right here and right here. And our answers here would be 0 and pi. Notice how it's not 2 pi, because we want our answers between 0 and 2 pi, but not including 2 pi. So theta would equal 0 and or pi. Those are our 2 solutions for that one. All right, last 2 here. We've got cosine x times tan x plus 1 equals 0. Just like we attacked this one by setting both separately equal to 0, that's exactly what we're going to do. So we set cosine x equal to 0 and solve that equation. We'll get x equals something. And we'll have tan x plus 1 equals 0. That happens to be the exact same equation we had up here. So solve both of these. This is already solved, so it's unit circle time. We're looking for where cosine is 0 now. So cosine is 0, cosine is the x, 0 right here and down here. So we're looking at pi over 2 and 3 pi over 2 as our two answers for that one. So we've got x equals pi over 2 and 3 pi over 2. And then for this one, we've got tan x equals -1. And tangent is -1 in quadrants 2 and 4, pi over 4 angle there. So we've got 3 pi over 4 and 7 pi over 4. So x equals all of those right there. Pi over 2, 3 pi over 2, 3 pi over 4, 7 pi over 4. All right, last one here. We've got 2 cosine 2x equals -1. First one to solve, and notice this one is like this other one. We got a double angle in there, got a coefficient inside of our angle. So we're going to have to use the general form to solve these. We've got cosine 2x equals -1/2. So we think, okay, what angle can I take this cosine of and get -1/2? Well, there's two places in the unit circle where that's true. -1/2 right here. Cosine is -1/2 there at 2 pi over 3. And then again, -1/2 here at 4 pi over 3. So we've got 2 pi over 3 and 4 pi over 3 is our two answers. Let's keep those in our head and write out their general formulas. 2x equals 2 pi over 3 plus 2 pi n. And 2x equals 4 pi over 3 plus 2 pi n. So that's the general formulas. We use these whenever there's a coefficient inside or if we're asked for the general solution. So we divide by 2, divide by 2, divide by 2. Got to solve for x, so we're dividing by 2. Remember, dividing a fraction by 2, we're dividing by 2 over 1, so we multiply by 1/2 instead. So we're dividing by 2 over 1, so multiply by 1 over 2 instead. And we've got x equals, well, the 2's can reduce. So 2 over 2, that's 1 pi over 3. You also could have made it 2 pi over 6 and then reduce it. We've got pi over 3 plus pi n. And then we've got x equals 4 over 2 becomes 2 over 1. So I got 2 pi over 3 plus pi n. So again, those are the general forms of the solution. That's GF for general form. And then I want to use these to get my individual solutions. Remember, the individual solutions are always whatever that first number is, or that first angle. So pi over 3 plus no pi's at all. So we got pi over 3 and 2 pi over 3 is our two answers so far. And then to get the second answer, I'm going to do pi over 3 plus pi and 2 pi over 3 plus pi. That's how I'm going to get the second answer. So I got to get these the same denominator. So I got to make it 3 pi over 3, 3 pi over 3. So pi over 3 plus 3 pi over 3 is 4 pi over 3. So the second one is 4 pi over 3. And that was pi over 3 plus pi. And then I do the same thing with 2 pi. 2 pi over 3 plus 3 pi over 3 is 5 pi over 3. And notice we know to stop there, because if we added another pi, then we would be at 8 pi over 3, which is more than 2 pi. So that's how we know there are those answers to number 23.